All right, let's jump right in. We're going to talk about something that, let's be honest, sounds pretty intimidating: deep learning. But what if I told you there's a tool out there that's specifically designed to make it feel more natural, more like the Python you already know, and, well, way more accessible for everyone? Let's get into it. First things first, you gotta appreciate just how much this stuff is already a part of our world. It's not some futuristic concept anymore. Neural networks, they are absolutely everywhere. And we're not talking about abstract theoretical science here. It's literally in your pocket right now, making your photos look better or figuring out what you're saying to your voice assistant. It's in your inbox, suggesting replies that are spookily accurate. It is fundamentally changing how we interact with technology, from the simplest things to the most complex. And that brings us to the big one. The question that I think stops a lot of smart people from even dipping their toes in the water. You see what this tech can do. You glance at the research papers filled with crazy-looking math, and you can't help but wonder, is this just for geniuses in an ivory tower? Well, I'm happy to report that we are about to bust that myth wide open. The whole idea that you need to be some kind of math wizard to get started is probably the single biggest misunderstanding in this entire field. And, there's a quote from the source material that just hits the nail on the head. It acknowledges that, yeah, the math can look scary, but then it gets to the real truth of it. To use deep learning is a completely different ballgame than to invent it from scratch. And that's the key. For most of the things you'd actually want to build, the practical concepts you're working with are way, way closer to high school level math than they are to a PhD dissertation. You don't need to derive the formulas to be able to use the tools effectively. So, if the door to deep learning is more open than we thought, what's the key to unlocking it? Well, for a huge number of people, the answer is PyTorch. This is the framework that has really opened the floodgates for developers. So what is it exactly? Simply put, PyTorch is this amazing open source library, originally from Facebook, that lets you build these incredibly complex neural networks in a way that just feels right. It feels Pythonic. It doesn't fight you. It works with you. And that makes a huge difference. And when you look at its story, it all makes sense. It's got the backing of a giant like Facebook, so it's rock solid. But its core philosophy, this eager approach, is the real game changer. It just means your code runs line by line the way you expect Python to, which makes debugging 1,000 times easier. And as you can see, this isn't just for hobbyists. The big players like Uber and Twitter are using it in production. Okay, so we can't talk about PyTorch without addressing the giant Google-shaped elephant in the room, right? The big debate in deep learning for years has been PyTorch versus TensorFlow. And this table really gets to the heart of the difference. See, with traditional TensorFlow, you had to first build this entire blueprint of your model, a static graph, and then you could push data through it. PyTorch flipped that on its head. It builds that graph dynamically, on the fly, as your code is running. This makes it so much more flexible and intuitive, which is why researchers who are always experimenting absolutely fell in love with it. I think this is the perfect way to position it. If you've ever used Keras, you know it's super easy, but can feel a bit like it has training wheels on. And if you've used old-school TensorFlow, you know it's powerful, but can be incredibly complex. PyTorch just hits that beautiful sweet spot right in the middle. You get all the power and control you need, but without all the boilerplate and the steep learning curve. Okay, so you're convinced. PyTorch sounds awesome. But how do you actually get started? What's the best way to get your hands dirty without getting lost? Let's map it out. This is the first big fork in the road, and it's where a lot of people make a costly mistake. You see these amazing custom PCs online with multiple GPUs, lights flashing, and you think, okay, I guess I need to drop a few $1,000s on a new computer. But do you really? The answer is a resounding no. Seriously, for a beginner, the cloud is, without a doubt, the way to go. You avoid that huge upfront cost. You don't have to spend a weekend wrestling with driver installations. You pay for only the computing power you actually use. And when your little project becomes a big one, you can scale it up with a click of a button. It's a no-brainer. And if the cloud is the answer, then Google Colab is the absolute best front door. Get this. It's a free online coding environment that runs in your browser. It requires zero installation. You just open a new notebook and you have instant access to a powerful GPU for free. All the friction, all the barriers to getting started, they're just gone. You can literally start coding the second this is over. All right, you've opened up Google Colab, you're ready to go. What's the one thing you need to understand? What's the fundamental atom, the basic building block of everything you're about to do in PyTorch? It all comes down to a single concept: the tensor. And please, don't let the fancy names scare you. A tensor is just a fancy word for a multidimensional array. It's a container for numbers. That's it. If you know what a list is in programming, you're 90% of the way there. A single number? That's a zero-dimensional tensor. A list of numbers? That's a 1D tensor. A list of lists, like a spreadsheet grid? That's a 2D tensor. See? It's just building on a simple idea. And here's what it looks like in actual code. That's it. Torch.tensor, and then your grid of numbers. This simple structure is how we represent, well, everything. A beautiful color photo becomes a 3D tensor, height, width, and color channels. A complex sentence becomes a 2D tensor of numbers representing each word. The whole game is about turning our messy, complicated world into these clean, simple grids of numbers that a computer can understand. So that leaves us with the most incredible question of all, doesn't it? We have these simple arrays of numbers, these tensors. How on earth do we go from that to a system that can look at a picture and see a cat, or a system that can write a poem, or even compose music? That journey from a simple grid of numbers to artificial intelligence, well, that's the whole magic of deep learning.